let's look at sockets for 0.1 inch headers. You make your prototype board and you put some headers on it. The most traditional kind is this simple header, and you can use a socket like this, a connector like this, where you have a housing and crimp pins in it. I always find these to be kind of a pain to assemble. So are there alternatives? Well, there's this kind. This is an MTA-100 connector, and it uses an IDC socket. So I want to see if these are any faster or easier to assemble than these. So I'm going to make this and time it. But let's look at these first of all. So the parts are right here. So I went to Mouser and I picked some representative parts. So there are a bunch for the traditional header. These have been made forever, and they come in a whole bunch of different names. I picked Harwin M20s, but there's also Amphenol Mini PV and Molex SL and Seagrid. But the Harwin M20 is kind of a lower cost brand. So what do you have to buy? You have to buy the header itself, 14 cents each. You have to buy the housing, just the plastic housing, 16 cents each. This is when you buy 100 of them. And you have to buy the pins, and they come on these reels for a machine, 4 cents each. So the total per pin is a little bit over 9 cents a pin. Now, surprisingly, the MTA 100s are cheaper. Again, you have to buy the header, 13 cents, and you have to buy the housing which has pins built in, 22 cents. And that comes to just under 6 cents a pin. How else are they different? Well, the width of the traditional header is 0.1 inches, right? So it definitely uses less board space. You know, if we compare it with this guy, and you can put these right next to each other. So that's one advantage of the simple header. But the height, if you look at the height is actually less on the MTA 100s, 0.62 versus 3/4 of an inch. 3/4 of an inch if you bend the cables over. You know, it helps tremendously that this is a right angle connector to start with. If you bend these cables over, you can just get it under 3/4 of an inch. Now the power, 3 amps for the traditional header, 5 amps for the MTA 100. The final kind of big difference is these sockets are designed for a specific wire gauge. So these red ones are for 22 gauge, and I'm going to use 22 gauge wires for this race I'm going to have. But the female pins, you know, they will work over a range of gauges. So they advertise that this pin works between 22 and 30 gauge. So maybe you have to stock fewer pins if you go with these. These you really have to use the wire gauge that matches the socket, otherwise it doesn't really work very well. Now, what tools do you need? For the MTA 100, the cheapest tool is this maintenance tool, and it's this. And it's just a tool with some pins on the end of it. You can try to use a screwdriver, but it doesn't really work. You really kind of need this tool. This is $30. For these, you need a tool like one of these. This is a cheap one, or a small step up is one of these. I think this was $10 at Radio Shack a long time ago. This was $25 at an electronics store. This is a generic one of these. The real one that matches the crimp pin it could be $400 from the if you get an actual Harwin crimper, it's probably $400. All right, so let's see how these compare to assemble. Well, actually, let's look at them a little bit more. So again, these are crimp pins, and how do they work? They work the same as like this kind. So what you have to do is get all the wires in there and crimp it together, and you're supposed to have an air-free joint. You crimp it enough so there's no air in there. So these are exactly the same, just scaled way down. And there's two. There's a part that crimps over the insulation, and there's another part that crimps over the wires. Now these are IDC connectors. They work the same as ribbon cables. Where's the ribbon cable I have over here? Oh, I had it. Where'd it go? Well, here's one. Here's a ribbon cable with a D connector on it. And here's one that doesn't have the cable in it yet. And you can see what you have in there is these little forks with sharp edges. And you stick the cable in, press this down, and there's a tool for that. This tool right here is this is the cheap option. And those sharp edges on that fork pierce the insulation and displace it. That's why they call it insulation displacement connector, and make a contact. And I think if you have the option, you want to use these whenever you can, because these are very, very easy to assemble. They take no time to assemble the connector. I think the connectors are a little bit expensive, but these days, I don't know, not that much. But, for example, you can put 0.1 headers on your board for something like this and bring it to a panel mount deconnector to get outside of your enclosure. These are great. And also board to board, I mean, you can't beat this kind to this kind for board to board connections. So let's try assembling pins. So I'm going to time it. I'm going to assemble one just like this. 6 wires in each end, and we'll just time how long it takes to do each one. Now, which should I do first? I'll do the crimp pins first. Let me get everything ready. So again, you need this tool. One thing to be careful with this tool is there are several kinds of these, and you need the kind that has the small rectangular hole, if you see on there. This kind, it's kind of larger, roundish holes. These are really for pins for D connectors, and this is the one you want. But definitely pay attention to which one it is. And you'll see also, each hole has a different range of a wire that it covers. And you can use this. This is the step up. The advantage of this is it ratchets, and it kind of guarantees that you get the same force for every pin. Now, one difference between these two is the width of the end here. So this is important to note because these are kind of split halfway. What you have to do is get that halfway point has to be exactly in the halfway point between the part that goes on the wire and the part that goes on the insulation. I find this one a little bit easier because the width of this happens to match the width of the crimper part that goes over the wire. So you can kind of align it on the edge. Whereas on this one, you have to pay attention and get it in the middle. So I'm probably going to use this one. I don't know. I'll do some with each. I need my wires. Here we go. We have to strip the wires. I mean, this is supposed to be the advantage, is you don't have to strip the wires for the MTA-100 connector, and you do for these. And you have to strip them at just under 1/10 of an inch, just a hair under a tenth of an inch. So to make that fast, I just have this line on this block, and I'll strip them using that to measure it. All right, so let's go. Oh yeah, I found that actually it's easier to mark the wire with a Sharpie a little bit. And if you do the same action repeatedly, that's kind of easier than doing each pin separately. So you'll see that I'm going to strip them all first, and then I'll worry about getting the pins on them next. Now it definitely takes practice with these crimp connectors. You have to you can't do it fast until you remember how to do it. So if you don't do this every day, you kind of have to practice a little bit, remember how to do it, and then you can do it quickly. Black on black, that's just barely visible. 1, 2, 3, 4. Oops, too big, too long. This is typical when you do this, what happens. 5, 6. There we go, stripped. Now I have to get these off. The easiest way is to just fatigue them off. You can try clipping them, but fatiguing them just works quickly. Now what I found, or the way I like to do these, is to hand, like kind of bend the crimp that holds the insulation by hand a little bit, just enough to hold it, so that when I use the tool, they hold together on their own. Otherwise, you kind of having to hold the pin and the wire and the tool at the same time makes it hard. This is the one I had to trim. This cutter is not that great. 2, 3. You want the insulation to just barely touch the wire crimping part, or maybe a little bit away from it. It is definitely a skill, and you have to crimp these. You really have to crimp these perfectly. If they're not perfect, they do not hold well. And I know some people will solder them in, but really you should not have to do that. And if you do, I mean, it's just yet another step. Last one, finally. Yeah, see these? I think the MTA-100s are going to be just better. All right, so now we can crimp. Now you got to pay attention to the sides, because this side is bigger than this side. First of all, I want the open end on the top, and the small side on my left. Yes. And you can align it right with the edge. If you can see this. Oh, come on. Well, that's what happens with these. That's why. Oh, look at that. Do it again. One more. This is a highly realistic test right here. Yep, that one's good. 1. This is made for lefties, I think, this tool. 2. 3. I'll switch to this tool for the rest. Made for righties. Nope, this side still. That's right? Yeah. See, and you have to. This one you have to get the middle of the tool right in the middle. Yep. 4. 5. Oh, did I screw that one up? Ah, oh, I did. Gonna have to do this again. Can I fix it? Let's see. No, kind of fixed. Ah, I don't think that's that great. I'm going to do this one again too. There we go. Yeah, better. Okay, now I got to shove them in the housing. I'm done. Even this can be a pain because if the pins are bent, they don't all go in. Oh wow. Yep, there it goes. 2. Come on. 3. 4. 5. That one was good. 6. Time. Ha. 10 minutes, 9 seconds. Wow. 609, whoops. 609 divided by 6. 101 seconds per pin. I am a champion crimper. 101 seconds per pin, that's horrible. Alright, let's try the MTA-100, see if we can do it any better. Now, what I found with these is you need something to hold them while you do it, and all you need is a piece of wood with a slot in it. Oh, I put it in the right way though. Well, actually, get the tool ready, and here we go. So all you do with these, no stripping, you put it in, use the punch down tool, and punch them in. 1. They look kind of ugly, these. That's one complaint. I mean, with the other ones, they're all hidden inside the housing, so you don't see the ugliness if they're ugly. 3. Now they call this a maintenance tool because I don't think, on a production line you would have some machine that does this. But we want to use a cheap tool for prototyping. 4. 5. 6. Well, just make sure they're really in. Time. Yeah, that's it. Wow. 1 minute 53 seconds. That's what I have. .8 seconds per pin. Well, these are way faster. But did they work? So we should try that also. Let's make sure it actually worked. I'll hook these up. Ooh, what's going on here? Maybe it didn't work. Oh yeah, you can maybe I damaged one of them. Points off for MTA-100. Yeah, you can kind of see it's bent. Oh no, maybe this is not on a board, so this is not the way to insert these things. There we go. This one. Yeah, I damaged these two? No, I think it's alright. No. See if they worked. Actually, I think the easiest way to do this is just through the little side opening here. 1, 2, 3, 4, 5, 6. Cool. So there you go. MTA 100s, definitely a very good alternative. I mean, they're cheaper, they're faster to assemble, they handle higher current. I kind of like them. Now, there's other options for these also, I should point out, but they're really the same. I mean, there's these Molex KK connectors, and those are kind of used on motherboard fans. This is a KK connector right here. But they handle 4 amps instead of 3 amps, and they cost a little bit more. But I've assembled these before, and they're the same. It's the same work that you have to do for the signal headers.